Hello everyone, I am Nada. Welcome to the course Internet of Things. Today we are going to talk about, let me share the screen, to talk about Raspberry Pi Pico W specification. Raspberry Pi Pico specification is defined as the components and features that Raspberry Pi Pico has. Raspberry Pi is an RP2040 based microcontroller that's announced on 30th June 2022. It has two Cortex M0 processor cores that runs at 48 MHz frequency, and you can also change this frequency in software up to 133 MHz for higher performance. Raspberry Pi Pico W has 264 kilobytes of SRAM and 2 megabytes of onboard flash memory. The RAM is used to store your programs and the data they need. Raspberry Pi RP2040 that Raspberry Pi Pico is based on that includes 30 multifunction general purpose input-output, that in abbreviation we say GPIO, and they are labeled, this GPIO, they are labeled from 0 to 29, like counting in Python, that is a start from 0, and here is also a start from 0. But you should note that pins are the ways that an MCU can talk to the physical worlds, but some of the pins are not broken out as physical pins. 26 pins of these 30 pins are brought out to the physical pin connectors on your Pico W, and one is connected to an onboard LED. This LED is connected to GPIO 25. Apart from this 26, 3 of these GPIO pins connected to an analog and digital converter that they are called ADC, and one ADC channel is connected to an chip temperature sensors. If we go further, we see that not all the pins are available on RP2040 are brought out to our Pico W pins. That is why that we will see in the chip that there is a gap in the numbering between the last basic general purpose pin, GP22, and the first analog capable pin, that is GP26, and we call it ADC 0. And I will show you in the next slide that how the chip looks like and how the numbering is. Raspberry Pi Pico W also includes 2 universal asynchronous receiver transmitter that we call it UART. It has 2 serial peripheral interfaces, SPI, and 2 inter-integrated circuits, and I2C in abbreviation. Buses for connections to external hardware devices like sensors, displays, digital to analog converters, and many more things. Raspberry Pi Pico W includes programmable input-output, that we call it PIO, that lets the programmer define new hardware functions and buses in software. It means that GPIO can play different roles, such as being I2C, SPI, and other roles. Also, Raspberry Pi Pico W has a micro USB connector which provides a UART over USB serial link to the Raspberry Pi 2040 microcontroller for programming. Also, you can do interaction with it and you can power your Raspberry Pi Pico. This is it's important that you know that you should hold down the boot cell button when plugging the cable into Pico W. Uh, in this case, it will switch the microcontroller into USB mass storage device mode and allows you to load new firmware. Why we need new firmware? Because we need to program it. So before we are able to program Raspberry Pi Pico, we need to load new firmware, and that is the way that you can load the new firmware on the Pico W. Raspberry Pi Pico W also has on board 2.4 gigahertz Wi-Fi, and the standard is 802.11n, and it has also Bluetooth connectivity. Pico also has a built-in temperature sensor and supports a wide range of programming languages such as C, C++, and MicroPython. Also, Raspberry Pi Pico W has it costs very low, and it's only $6 that you can prepare it. So there is a warning here that you should be very careful about it. As you can see here, is that Pico's pins are designed to be fun and safe way to experiment with physical computing, but should always be treated with care. Why? Because there is a possibility if you accidentally or deliberately you connect two pins directly together, the short circuit happen. And the short circuit occurs when an electrical circuit is connected in a way that enables current to flow through an unintended path with little or no resistance. This can cause a sudden increase in the amount of electrical current flowing through the circuit and leading to overheating, damage, or even fire. So a short circuit can be caused by a variety of factors, and including damage or exposed wires and faulty components or incorrect wiring. So you should be very careful when you're working with your Pico. Raspberry Pi Pico W, at glance, you can see here, we have a CPU that it has a 32-bit dual-core ARM Cortex-M0, and it works at 48 megahertz. And as I said and mentioned in the software, you can configure it to 133 megahertz, and it has a RAM, and the RAM is 264 kilobyte, and it has a storage of 2 megabytes external flash RAM. Also, it has 26 pins or GPIOs. Also, it has 3 ADCs, and I will explain what is 3 12-bit ADC pins. That is used for resolution. Also, it has 8 slices and 2 outputs per slice for 16 total for PWM, and the clock that is on-chip clock, and it has sensors, on-chip sensors, temperature sensors that is connected to 12-bit ADC channels. It is built-in sensors, you should notice that. And it has LEDs, that is onboard user addressable LED, and we will work later on with this LED, how to connect it and how to make it turn on. And it has bus connectivity. As I mentioned, it has 2 UART, 2 SPI, and 2 I2C digital communication. And also it has programmable input output. You can do hardware debugging by single wire debug, SWD, and also it can be powered up to 5 volt via macro USB connector, and through the pins you can power it 3.3 volt, and the interval of between 2 to 5 volt via the V6 pin. I will show you all these pins that their label and where they are positioned on the board. So I brought some notes here that the word out in 3 volt 3 out, when we see later in the board, means that you can take 3.3 volt power from voltage from your Pico W and supply other peripherals. It means that from these pins you can get 3.3 volt voltage, and you power other peripheral, other devices that are connected to the to this Pico and needs voltage to be turned on. Okay, so let's see what is ADC, analog to digital converter. If you look at this photo, we have a sensor here, and it has 3 pins, VCC, and signal data. We call it signal or data, no difference, and a ground that is connected to the ground. Data is this is something that I will explain later more with detail. But when we are sending data to this Pico, voltage is coming here, and as we know, voltage is an analog signal. So, but the Pico that we have here needs to work with digital signals. In this case, we need ADC, analog to digital converter, that converts this voltage that is in analog to the digital, that enable Pico W work with this kind of signal. So one of the tasks of ADC is conversion, which converts analog signal to the digital signal. Another task is mapping. What does it mean? Let's say in our the resolution of a ADC refers to its ability to accurately represent a range of analog values with a corresponding range of digital values. In similar terms, when an ADC has more bits, it can divide the range of analog signals more finely, which leads to a higher resolution. So, for example, a 10-bit ADC represent 1024 different values, which is 2 power 10, while a 11-bit ADC can represent 2048 different values, which is 2 power 11, and allowing it to capture more detail and provide a more accurate digital representation of the analog signal. So you can see here 0 to 3.3 volt voltage. When it comes to represented in a digital voltage, it becomes as a unit of bits, and it will be shown like, and the values will be shown like 0 to 1023. in 10 bits, which is, or I can have more bits, like 11 bits, or more bits, 12 bits. That is, when I choose more bits, it means more resolution. So as you can see, ADC does two tasks: conversion and mapping. Okay, the Raspberry Pi Pico pins seen from the top of the board. As you can see here, a Raspberry Pi Pico talks to hardware through a series of pins along both its edge. Yes, here GP0 to 1, 2, 3 up to GP28. Raspberry Pi has 40 pins, as you can see, 1 to 40. They are labeled on their side of the board. As I mentioned, this is under the board, and you can see that with 3 labels with their numbers on the top of the board: pin 1, 2, and 39. You can see here 1, 2, and 39. The things here is that GP0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and we don't have 23, 24, and 25 that I mentioned the reason. Some pins are on RP2040. They are not bring out on the Raspberry Pi Pico. So here also we have ground 1, 2, 3, 4, 5, 6, 7, 8. 8 ground. And also we have VBus, VCs, and 3 volt output voltage. And as you can see here, we have ADC0, 1, ADC1, and ADC2 here, and 1 ADC here that's connected to 1 pin. So this is how Raspberry Pi Pico W is seen from the top of the board. We will explain this Pico W diagram with detail more in the next lectures. So thank you for today. If you have any question, please Slack me, and goodbye.